Before starting this video, I want to let you guys know that Coding Cleverly also has a Patreon page. So go to patreon.com/codingcleverly and you'll see that there is a Patreon page that is available, and you guys could support the channel by just joining any one of these tiers. That would also motivate me to provide better and better content. So all you got to do is go to this page and show some love to Coding Cleverly. Alright, enough with the shameless plug. Hey there, my fellow coders. I hope you're all coding. Today I'm going to be talking about the difference between recursion and iteration. First, we're going to look at what a recursion is, and then we're going to go back to iteration, and then we're going to give a small comparison between the two. You could see that I have a node.java file opened up, and you can see that there is the string data and there is a node next. The constructor just assigns the data value, which was passed in the input parameter, to the this.data, and this.next is assigned to null. Set next node will get a node, and then that would be the next node for the current node, and then the get next node will just return the next node for the current node. Now in the linked list.java file, we have all these methods that we've been covering before, like the toString method, which actually prints the linked list, the remove head method, which removes the head, add to tail, add to head, self-explanatory. Find node recursively and find node iteratively are just the two different functions that we're going to be discussing today. What is recursion? Have you ever considered what might occur if a function or method was called from within another function or method? This is known as recursion, and it can actually increase the effectiveness of your software. It can be applied to issues that can be solved in steps, frequently those that you would otherwise solve iteratively. It will also be utilized in a few of the sorting and traversal techniques that you will later on see in my videos. Now for this program here, we're trying to find a node from a linked list, but we're using both of the methods. One, we're using the iterative approach, and then the other one we're using is the recursive approach. Before, let's go to the iterative approach and see what's happening here. So over here for the iterative approach, what you have is a return type of node. Seems like you want to get the node what you're looking for, right? So you pass in the data for that node. Suppose I say that data is a string data, and I say I want something like Sally. The name Sally is the node's data, and I want that. So you're gonna create a current head node, and then you're gonna assign it to this dot head of the linked list. You're gonna go on a while loop and just iteratively go one at a time, and you're gonna check a condition while current node not equal to null. So if the current node dot data is equal to the data that was passed in, return the current node. You can see the return type there matching, and if it doesn't match, so you keep on moving iteratively. So current node is equal to current node dot get next node. And if no case matches here, so in the case if the head was empty or if the data element wasn't present inside of the linked list, you'll just return null. So that was the iterative solution. It was pretty easy. And now we got to map this entire solution as a recursive solution. So this is the recursive solution to that method. Now we have to keep in mind the following scenarios before solving a recursive solution. First of all is the base case. And in this case, we have two base cases. One is this one, and the second is this one. You might have one base case for your problem, but in this case, we have two base cases. Now the base case one, which is right here, is saying that if the linked list reaches its end, return null. So the current node is equal to null, just return null. The second base case is this one. It's saying return the current node if its data value matches the data argument. Now this portion here is the recursive case, and what it says here is that return a call to find node recursively with the next node as an argument. So there you go. The next node, which is current node.get next node, will be in the argument. Recursion has an additional overhead of function frames on call stack. The thing that goes here is that we have the return type of node, we have find node recursively, we pass in the data, which is over here, we pass in the current node, which is the current node right now, and then what we do here is that we check the current node is null. If it is, just return null. In other case, if we said the current node.data is equal to the match data of the argument, then we return the current node. In the other case, if it doesn't happen, like if we want to iterate like this, just keep on going further, we call the function again. So the calling the method more than one time, and within the same function, that's the process of recursion. So just keep calling the function. So return this dot find node recursively. So you have the same thing passed in, which is the data, but here the difference is that instead of the current node, now you're gonna get the next node of the current node. So it just can keep going until you reach the end of the linked list. That's how you're gonna solve the find node problem using the recursive process. What is faster, iteration or recursion? Recursion has an additional overhead of function frames on the call stack. If you look at the difference between the two and ask what is faster, well, if you look at recursion, recursion has an additional overhead of function frames on the call stack. So whenever you're calling a method inside of the recursive process, it's actually creating additional overhead of function frames on the call stack. In the case of iteration, it doesn't even do stuff like that, and iteration is actually much more efficient than compared to recursive. Iteration can be used to repeatedly execute a set of statements without the overhead of function calls and without using stack memory. This line defines everything, that iteration is faster, it's easier to optimize iterative codes, and they generally have polynomial time complexity. Thank you for watching this video, subscribe to the channel, and see you in the next one. Peace out.